Hi friends, in last session we derived the equation of continuity, that is del dot J is equal to minus dou rho by dou T, which describes stationary current, that del dot J is equal to 0, but for time dependent fields del rho by dou rho by dou T is not equal to 0, and so del dot J is not equal to 0. That's why the Maxwell suggested that for time dependent fields the definition of total current density is complete, and he added a term J dash to it to be recognized as a displacement current density. Therefore, by arriving at Maxwell's field equation, we shall briefly discuss the displacement current. We shall show how that the Maxwell changed the definition of total current density to adapt the equation of continuity to time dependent fields. That's why today we are deriving or modifying the Ampere's law, that is displacement current. For the static electromagnetic field, according to Ampere's circuital law, we can write the closed surface integral BdL is equal to mu 0 I. Here we are just placing the B in place of H in place of B. So I am writing, so surface integral H dl is equal to I, as we know that I is equal to surface integral of J dot ds. So changing the line integral into surface integral by Stokes theorem. So we just write this line integral into surface integral. So that's why both sides of the term equals. So in this case, one term is considering the elemental area of the line, while the second here this term is referred as a surface, change in surface, here change in length. So for the convenience we use the Stokes theorem and we convert this line integral into surface integral. So we get the surface integral curl H is into ds is equal to surface integral J dot ds. But as we know, the curl H is equal to J, and that is static electromagnetic field. Now let us put it into equation continuity, which is divergence of J is equal to minus dou rho by dou T. So take the divergence. So in place of, I am writing that del curl H. So divergence of curl H is equal to minus dou rho by dou T, just taking the divergence on one side. But divergence of curl H is 0. So del cross H is 0. So we get 0 is equal to minus dou rho by dou T. The equation 1 leads to static conditions in which charge density is not changing. Therefore, time dependent is nothing but changing. Therefore, the time dependent fields equation 1 should be modified. That equation is what? Curl H is equal to J. So that curl H is equal to J should be modified. So Maxwell suggested that the definition of total current density is incomplete and advised to add something to J, and it is, let it be J dash. So then equation 1, that is curl H is equal to J, is curl H is equal to J plus J dash. So here we are taking the equation number 2. Now what is the J dash, why it introduces? So you have to identify the J dash. So take the divergence on both sides. So divergence of curl H is equal to divergence of J plus J dash. So as we know, the divergence of curl H is equal to 0. So 0 is equal to divergence J plus divergence J dash. Now take the side divergence J dash in LHS, left hand side. So we get divergence of J is equal to minus divergence J, and as we know, the minus divergence J is nothing but dou rho by dou t, that is the continuity of equation of continuity. Now we know that rho is equal to del dot d, so divergence of d. So just substitute the value, that is the rho here. So we get divergence of J dash is equal to dou rho by dou t into del dot d. So all these are the vector quantities. Now just rearrange it. So divergence J is equal to del dot, so we know the rho is equal to dou d by dou t. So I am taking here rho into d is dou d by dou t. So divergence of J minus dou d by dou t is equal to 0. Now this equation is true for any arbitrary value. So we can put J dash is equal to dou d by dou t, and taking the modified form, that is curl H is equal to J dash plus dou d by dou t. This is the modified form of Ampere's law, and that modified Ampere's law is having the two terms. Since the J arises due to the variation of electric displacement, means J dash किसकी वजह से आता है? ये आता है electric displacement with the time. So that displacement is D, capital D. It is termed as displacement current density. So according to Maxwell's, it is just as effective as J. So the condition, or we can say the conduction current density in producing a magnetic field. So this is the first term. That first term describes, again in simple form, conduction current density attaching the J dash indicates that the current is due to the moving charges. Here the current due to the moving charges. So second important term is that, so the final equation curl H is equal to J dash plus dou d by dou t is displacement current J dash is related to the electric field, where so D is the vector field. So as we know, the D is nothing but the F long E. It is not possible in case of time varying fields to deal separately with electric field and magnetic fields, but instead the two fields are interlinked, giving rise to electromagnetic field. Thus J dash results into uniform of electric and magnetic phenomena. And the third term, the J dash is a good conductor and is negligibly compared to J at a frequency lower than the light frequency, that is the 10 to the 15 Hertz, as an evident from the curl H is equal to J dash plus dou d by dou t. So this is the modified Ampere's law with their two significance, which is done by Maxwell's. So as we know the current equation of continuity and the displacement current, now we can modify or we can derive the Maxwell's four equation in differential form and integral form. So I hope you understand the displacement current. Thank you for watching this video.